So we're in 1.2. This section covers powers and exponents. We should be in our books on page 10. You don't have to turn there just yet. We may turn there throughout the lesson, but you can just watch the PowerPoint screens for your examples. All right, so just like yesterday, today we are starting off with a little bit of vocab. We have 3 terms, and they kind of blend together, to be honest with you. A power and an exponent is basically the same thing. All right, raising something to a power results from repeated multiplication of the same factor. Well, the base is the actual number being multiplied, all right? And then the exponent tells me how many times the base is being multiplied by itself. Got a little typo in there, but that should say multiplied, that last word. All right, so just take a minute and write these down. All right, so now let's look at example 1, using exponents. So here I want to talk about first the repeated multiplication that you're looking at. So with repeated multiplication, I just look at how many times the number is being multiplied by itself, and on A, how many times is 13 being multiplied by itself? 4. So it's going to be 13 to the 4th power. Now, on your classwork in a minute, it asks you to write it on, I can't remember if it's as repeated, but it also asks you to write it in words. So I just want to go over that really fast. If you're going to write the power in words, you're simply going to say 13 in words to the 4th, and again, you write this out in words, power. 13 to the 4th power. All right, so writing it as an exponent, write the product as an exponent and then in words. So what about B? Go ahead and try to write that repeated multiplication as a power. Okay, what would it be? 2/10 to the 5th power. And then to write this in words, you're going to say 2/10 to the 5th power. All right, and then box that in. All right, 2/10 to the 5th power. All right, now with the variables, we're just going to write the variables as exponents. So go ahead and write that repeated multiplication, write the product as a power. I think that's how the directions say it on your classwork too. Write the product using an exponent. That could be another way of saying it. All right, so for n, what would you say? N to the 6th power. And for x, what would you say? X to the 3rd power. Very good. Or x cubed, either one. Now I want you to kind of experiment for a minute in your calculators. I want you to evaluate these 3 exponents, 0 to the 3rd, 0 to the 6th, and 0 to the 7th power. What conclusion can you draw based on these answers? Once you find your answers, what conclusion can you draw about raising 0 to a power? I want you to just write it in your notes once you evaluate these 3 exponents. Right, so what did you get when you evaluated all 3 of those? What did you get? What was your answer? 0. So it doesn't matter what power you raise 0 to, your answer will always be 0. So the answer is always 0. Doesn't matter what you raise it to. Now I want you to evaluate 1 to the power of 0, 5 to the power of 0, and 12 to the power of 0. What conclusion can you draw about raising a number to the power of 0? Okay, and what did you get? 1. You get 1. So the answer No matter what number you raise to the power of 0, the answer is always 1. And these are rules about exponents that you just have to remember, you have to memorize. So raising a number to the power of 0, your answer will be 1. Raising 0 to any power, your answer will always be 0. All right? So that's just some rules for exponents. Now in example 2, now I'm going to substitute a value for the variable and then solve. So we actually did this yesterday. Now we're just blending what we learned yesterday with our lesson today on evaluating powers, and we're going to substitute and solve. So remember on these, it's 3 steps. You start with the original expression, x to the 4th, so write it in your papers, x to the 4th under example 2, and then underneath x to the 4th, you're going to make your substitution 5/10 raised to the 4th power. All right, and then we need to evaluate that. 5/10 to the 4th power in our calculators is what? What now? 6.5. Very good. Right? 6.5? 0.65?
0.
No.
625.
625. 625. That's right. 625. I was missing a number. All right. So, what is that? 625 10,000ths. Okay. So, any questions there? Hundreds, thousands. Yeah. 10,000ths. Any questions? So now I want you to take this m value of 3, okay, and substitute it into each question. So, or I'm sorry, each number. So m to the 2nd, substitute in 3. M to the 3rd, m to the 4th, m to the 5th. Go ahead and do that real quick. So we make our substitutions. 3 to the 2nd power, 3 to the 3rd power, 3 to the 4th power, and 3 to the 5th power. All right, now let's say our answers together. 3 to the 2nd power is 9. 3 to the 3rd power,
27.
3 to the 4th power,
81.
and 3 to the 5th power,
243.
243. All right, did you get them all? All right, just simple substitute and solve. Now the last example deals with formulas. So let me ask you this. Why do you think out of all the formulas that we could have learned today, we've got rectangles, we have even circles, we have all these different formulas, why these 2 formulas? Why do you think we're learning these 2 formulas in this lesson? Anybody have a guess? Huh?
They're important.
Well, yeah, they're important. Area of a square, volume of a cube. Anything you see in that formula that might have something to do with the other examples, Andrew?
All sides are the same.
Not that the signs are the same, Cameron.
Area of a square.
Okay, yes, and particularly, what is involved, Janie? An exponent. Very good. So now I'm dealing with formulas that actually have an exponent in them that I'm going to have to evaluate. So go ahead and write down these formulas, and then we'll look at an example. Okay, so let's look at an example of this. Okay, so what kind of figure is this?
Squares.
Nope.
Cube.
It's made up of squares, but it's a cube. Okay, so a cube is actually made up of squares. All the faces are squares. You guys remember that? We're learning that in last year we learned it, if you had me. Okay, so using powers and formulas. So instead of drawing the cube on your paper, your original problem will be your, anyone want to fill in the blank? Formula. It'll be your formula. Very good. So formula to find the area is A equals S squared. So we make our substitution. What is my side value in this figure? 20. And 20 squared is 400. And that's my final answer. I don't need anything else.
No inches.
I need my label. Inches squared. Is it okay if I say square inches? Is that the same thing?
No.
It actually is. It is. So you can say square inches if you want, but this is the label, how I'll write the label. All right, you think you can do volume? Volume equals, what's my formula? S cubed, or S to the third power. Go ahead and make your substitution and solve. All right, so substitution, V equals S to the third power. And what, oh, not S to the third power, what's my substitution? 20 to the third power. And what would my answer be?
8,000 inches cubed.
8,000 inches cubed. All right, guys. And if you understand that, that is everything you need to know for 1.2.